Hello and welcome to today's session, Material Handling Efficiency and Infrastructure Optimized with Lithium-Ion Batteries and Fast Charging. My name is Michael Levins and I'm Group Editorial Director for Peerless Media's Supply Chain Group, which of course includes Modern Materials Handling Magazine, and I'll be your host for today's session that's being brought to you by Green Cubes. Now, as we've been covering in the pages of Modern Materials Handling over the past few years, when it comes to the electric lift trucks, one of the biggest trends is the rapid growth of lift trucks powered by lithium-ion batteries. Now, not only do analysts predict strong growth for lithium-ion powered units, lift truck OEMs are coming up with new and more models designed to take advantage of lithium-ion characteristics such as energy density in a small form factor and fast charging that makes lithium-ion well suited for opportunity charging. And as many managers are learning, lithium-ion batteries paired with high-frequency and modular chargers work to enhance an organization's ability to opportunity charge without battery maintenance. Now, in turn, that's reducing infrastructure costs and eliminating common workplace hazards, and we're all looking forward to doing that. Now, and to take us on this journey today, we're joined by Robin Schneider, PhD, Director of Marketing at Green Cubes Technology, and Jeffrey Vanswall. And Jeffrey is Chief Marketing Officer at Green Cubes Technology. Now, Robin has more than 15 years of experience in the marketing of batteries and power technology. She started her career in the battery industry working at Micropower Electronics and subsequently worked at Inventus Power and Phasium. Now, she holds a PhD in materials science from the University of Texas, where she studied with John Goodenough. And he's the gentleman who earned a Nobel Prize for his role in the invention of the lithium-ion battery. And Jeffrey's range of experience includes engineered power solutions for OEM and Fortune 1000 enterprise customers. Now, prior to joining Green Cubes, Jeffrey was a senior marketing executive at Inventus Power and Micropower Electronics, as well as Alcatel and ADC Telecom. So we have some terrific experience joining us today. Now, before I turn the podium over to Jeffrey, just a quick note before we get rolling here. We will have time for a short Q&A session after the presentation. So please make sure to submit your questions at any time while our team is going through their discussion today. We're going to get to as many as we can following the discussion, but if we don't get to your question today, we're going to be moving those over to Robin and Jeffrey, and they'll be able to respond to you via email following today's event. Well, we have a lot to cover today, and now I'm going to turn the podium over to Jeffrey to get us started. Jeffrey, it's all yours.
Yeah, thanks, Michael. That was a great introduction. So first of all, today you're going to learn about opportunity and fast charging using the latest technology embedded in lithium-ion products. And this will include everything from fast charge batteries, high-power multi-output chargers, as well as using the Internet of Things or IoT capability. After a brief introduction to Green Cubes, we're going to discuss some surveys and market research that we've collected on the use of lithium power solutions within the motive industry. And then we'll discuss specific charger technology as well as specific battery technology that is either available or coming on the market in the very near future. Green Cubes, first of all, Green Cubes designs and manufactures rechargeable lithium-ion battery solutions that are safe and accessible. These solutions basically ease the migration for enterprise customers away from what we would call legacy power technologies. And these legacy power technologies could be either, say, lead-acid batteries, but also internal combustion engines as well. And, our vision is really to design platforms to help accelerate the adoption of clean energy mediums for enterprise customers. A little bit about Green Cubes. So first of all, among the providers of lithium solutions, we stand apart with our precision engineered lithium power solutions for material handling equipment, hospital systems, as well as telecom infrastructure. We currently have over 300 employees across the worldwide or globally, and we've designed over 100 power systems in the last decade. So a common theme across all our products, and it's actually a differentiator for our products, is that we utilize remote monitoring and tracking to provide a solution that the entire enterprise organization can use to better manage their assets. So this is a very common theme across all the different markets and products that we offer. If you look at the different lines of business within Green Cubes, we basically have 3 lines of business. So the first line of business is our mobile OEM power solutions. So these are typically OEM products that are designed and engineered for mobile workstation manufacturers. And these could be medical mobile workstation manufacturers or industrial workstation manufacturers. This combines a combination of battery, power conversion, and charging, and predominantly used by the leading workstation manufacturers. Secondly, the second division is our telecom and network power group. So these are battery backup units that are rack mounted and typically either used in data centers or telecom network centers. So currently much of that backup power today is lead acid, and our solutions are effectively offering a cleaner and greener solution for backup power. And of course, last but not least is the products that we offer for the material handling and aviation segment. So these are our motive products, and they include a range of batteries as well as chargers to provide an end-to-end solution for enterprises that have a need for material handling as well as ground service equipment. If you look at the battery models that we offer for the motive segment, we offer over 200 battery models for material handling equipment, and this covers the range of class 1, 2, and 3 products. So this could include hand rider trucks, it includes electric narrow aisle trucks, as well as electric motor rider trucks or forklifts. So we've got a full suite of products for any type of enterprise that would be using material handling equipment. You know, across these different models, we support, of course, multiple voltages, sizes, capacities, but also some of the more esoteric features like communication protocols, different types of cable connectors, and various configurations like that. I'm going to hand the presentation off to Robin, and she's going to talk about the state of the industry and also share some of the market research that we've been performing and collecting on this segment.
Thanks, Jeff. So the first part of this presentation is going to be looking at what's important to the industry and some power trends. So what we've seen is in recent surveys of the material handling industry that most enterprises are focused on primarily on improving efficiencies, throughput, and workplace safety. And I'm going to show you how lithium-ion batteries paired with high-frequency and modular chargers enhance an organization's ability to opportunity or fast charge without battery maintenance. And that in turn reduces infrastructure costs and eliminates common workplace hazards. So let's first take a look at some of these surveys and trends in the electrification of material handling fleets. So this is actually a survey from Peerless Research Group, the publication that is putting on this webcast. So the readership and the audience in attendance today would have answered this survey. And what we see here is that the topics of interest are first, that safety is a major issue, and power technology is not far behind. And then you see that cost containment is an issue, cycle life, or cycle times and throughput. And then finally, environmental sustainability is farther down on this list, but it's growing in importance. So all of these can actually be addressed in some way with battery and power and charger technology, and we'll talk about how that happens. Another part of this survey shows where investments are being made. And here you see IT infrastructure growing, and that's related to the IoT systems that I'll be discussing later in the presentation. And in traditional physical infrastructure, lift trucks and accessories have the majority of the spend. So again, all of this presentation is relevant for those topics. So to set a context for this presentation, let's look at some of the ways in which batteries and chargers contribute to inefficiencies at a high level. And we can keep these in mind when we look at potential improvements. So getting operators just to plug in and properly water batteries is the first issue. There's also issues with long charge times and temperature stabilization times. Connector and cable damage is really common with frequent use of batteries and chargers. And there's always the issue as the battery starts to degrade over its lifetime of having enough capacity to make sure that the operators can finish their shifts or finish the work that's needed. And finally, the overuse or underuse of various pieces of equipment leading to uneven wear and tear on the equipment and accessories so that they're not used properly across the organization. And now let's take a quick look at the basic power options that are available to you. There are two fundamental ways to power equipment, with a fuel-based system or an energy storage or battery system. Roughly half of the material handling equipment in use today uses propane or diesel-powered internal combustion engines. And although these have high maintenance costs, and there are sustainability and pollution concerns, especially obviously for indoor use, their overall market share is not expected to change substantially because the alternative green fuel cells is still in relative infancy. Nevertheless, we do expect fuel cells to grow over time, but what we see is a really dramatic shift in the market is in the use of stored power and a conversion from lead-acid batteries to lithium. And this is on the cusp of a really serious change in adoption. Because lead-acid is very problematic, it has a low purchase price, but it can only really be used for a single shift. And it requires regular watering and maintenance and monthly reporting to the government. It has a lot of environmental issues, and workplace safety issues are really common. And lithium-ion, on the other hand, it has multi-shift applications, long runtime, low weight, small size, it's fast charging, and it's environmentally friendly. Reflecting my comments on the first slide, we can see the adoption rate of these technologies over time, and this research by Interact Analysis. What we see here is a very slight decline in lead-acid because some electrification will actually go from combustion engines to lead-acid, and a small growth in fuel cells. But what we really see is a very, very rapid growth in the use of lithium-ion for all lift truck power. And looking at this in another way, you can see the adoption rate in various classes of trucks. So what we see is high adoption of lithium-ion across all classes, but Class 1 and Class 3 are adopting lithium-ion faster than Class 2. And in the end, roughly half of all material handling batteries are expected to be lithium in just the next few years. So now let's talk about opportunity charging. Opportunity charging or fast charging, which does not lower the battery cycle life, is a key differentiator for lithium-ion. It enables true 24/7 or nonstop operation of your material handling equipment. However, typically fast charging requires special infrastructure for high power utility connections and possibly 2 battery charging cables and things like that, and retraining the workforce. So we're going to talk about how all of these things would affect your organization. So opportunity charging is not a new concept in this market, but lithium brings improvements and better actualization of the concept that an operator can just plug in the battery during breaks and lunch and enable 24/7 operation without a battery swap. Lithium batteries can truly be charged in 1-hour time frames and better tolerate a wide range of depths of discharge. So a short break can actually bring a 25% charge back to the battery. And just doing this on a break will keep it in its ideal state of charge and have a very, very long cycle life for the battery. And because lithium batteries are protected by their battery management system or electronics, there's no degradation with overcharging or undercharging, or in fact, you can't overcharge or undercharge it. They're able to continuously plug in these batteries during the off periods and don't need to worry about the state of charge at all. And this prevents unexpected shutdowns. Much of the advantage of lithium-ion at the system level comes from its charging properties. And these may be kind of confusing graphs for you, so I'm not going to go into them in much detail. But basically, for all batteries, there's a constant current phase and then a constant voltage or high state of charge phase where the battery is basically fast charged and then topped off. For a lithium battery, it's mostly fast charged, but lead acid is only charged to about 80% in that phase. Also, the charging for a lithium-ion battery approaches about 100% efficiency versus only 80% for lead, and this results in less energy loss and more savings on your electricity bill. Finally, lead can have premature aging and loss of cycle life due to both reduced charge levels and over discharge, even in a so-called deep discharge lead acid battery. So lithium-ion is just much more tolerant and forgiving, and you can use the full rated capacity and realize the full cycle life promise. So let's look at how the details of how each of these are charged. So lead acid, basically you discharge the battery fully and charge at a C/5 rate, resting for an 8-hour cool down period, and then equalize the battery on a weekly basis. And you can basically do 1 full charge and 1 full discharge per day. And if you do that, you can get 500 to 1,000 cycles from a flooded lead acid battery. And that's what generally lead acid batteries are advertised as. But if you opportunity charge the battery, which is typically 25 amps per 100 amp hour or a C/4 rate, or fast charge it, which is typically 50 amps per 100 amp hours or a C/2 rate, this will either shorten or violate the manufacturer's warranty and usually puts the cycle life more like 200 or 300 cycles. So that's less than a year. So with lithium-ion, regardless of the state of charge of the battery, it'll efficiently accept the power and increase the state of charge. Battery can be immediately discharged and used. There's no need to cool it or rest it. It can accept a full charge in a little over an hour, and you still get exceptionally long cycle life of 2,000 to 4,000 cycles to reach 80% of the original rated capacity. And then you also can get the full warranty even if you're opportunity charging. What are the best practices for opportunity charging? So these are going to be the same regardless of lead acid or lithium-ion. So you want to do a power study where the battery activity is monitored. And based on that data, you can determine whether there are adequate opportunities for charging throughout the shift. If there's no downtime for the equipment throughout the shift, then the batteries will need to be charged an hour before the shift. Single shift versus multi-shift operations can determine the value of opportunity charging. If you only have a single shift operation, a fully charged lithium-ion battery should be able to power that through the shift. But it's when you add a second or third shift that opportunity charging generally needs to be used in increments to ensure that equipment is powered throughout all the shifts. You need to look at the existing lead acid chargers to determine if they're compatible with lithium-ion batteries, which generally they are, but not always. And assess the power output of those chargers and the charging infrastructure to look at the power rating to make sure that it's high enough to do the opportunity charging. And Jeff's going to actually talk about this in more detail in just a few minutes. And then you can consider a multi-voltage battery if opportunity is desired, but there's not adequate downtime in a shift. This is a special fast charging battery that I'm going to discuss later in the presentation. So now I'm going to turn it over to Jeff to talk about our charging systems.
Thanks, Robin. I'm going to provide a summary of a product that we just recently introduced. So it's a motive charger for lithium-ion batteries. A couple things I'll point out, and I would say these are found on most modern battery chargers, hopefully if you're assessing multiple vendors. But first of all, it has CAN communications, right? And what does that mean? That means the battery is actually talking to the charger and indicating when to start and stop charging, the current rate, that it should be charging at, the voltage levels, all of that. So it's basically a smart battery talking to a smart charger. So the CAN communication, as an example, indicates when charging should start or stop, and this is really dictated by the battery. So the battery itself will indicate when it needs more power or less power. Secondly, the CAN communication allows the charging to start or stop without any intervention by the operator at the end of the day. This solution that we offer, it actually has 3 outputs. That means it can charge 3 pieces of equipment concurrently. And the nice thing about that is you can have a single drop for electrical service and then be able to accommodate charging 3 pieces of equipment simultaneously. Another interesting feature of our product is that it is offered in 15 or 30 kilowatt increments. So it has 2 power supplies embedded in it, and you can have a 15 kilowatt version, or you can add another power supply and have a 30 kilowatt version. And as I mentioned earlier, it's each of the cables supports multiple outputs concurrently. So the voltage range supported on this charger is anywhere from 20 to 120 volts. And like I said, you can connect to the equipment and it will figure out the voltage and start charging at the appropriate voltage. The other nice thing is that this is a high frequency charger, and what that means is the footprint is relatively small compared to some of the older chargers that you're going to see out there. So this charger, it's hard to tell by this image, but this charger is about the size of a mailbox that you would see at the end of your driveway. So it's a relatively small unit, it's a relatively light unit, and that means that it could be wall mounted, but it could be pole mounted, it could be mounted high up above the floor to just recover that real estate on the floor. And tying back to the high efficiency, this charger has about 97% efficiency. And what that really means is that you are not wasting electrical power when the product is in use. Effectively, 97% of the power that flows through the charger is delivered to the battery. So you have very little waste occurring, electrical waste occurring when the charger is not in use. Here's a little more insight into the product itself. As you can see there, it has a modular power supply, 2 15 kilowatt power supplies. It's actually a fast charging charger, so that can take a lithium-ion battery from 0 to 100% state of charge in 1 hour. As I mentioned, it's small and lightweight, so there's more options for installation. It can be wall mounted or even pole mounted in a higher spot. You have your option to either go with a 15 or 30 kilowatt version. And as I mentioned earlier, it supports 3 different batteries with 3 different voltages all at the same time. It does have a touchscreen display, as you can see there, and we've just got some screenshots of the display itself, but you get a nice visual indication of how each of those batteries are charging. If you look at chargers in general for the lithium-ion batteries out there, this to me is more or less, thought I put together a checklist of some of the common features offered by most charger manufacturers. And these really represent features not only needed now within most enterprises, but also in the future as well. So this is a good checklist to kind of future-proof the purchase of any motive chargers. And you know, the most common features out there utilized and needed today: high frequency electronics, high frequency charging, a compact footprint, supporting multiple charging ports with different voltages, auto detection of the charging profile via CAN bus. That's critical, right? You want to be able to just connect the battery to the charger, and then it figures everything else from there. IoT, embedded IoT, Internet of Things, this capability. So this allows, the fleet operator to manage the charger, and there's multiple methods to connect into the network to provide that visibility. So one is, via wired interface, such as an Ethernet or USB, or even a wireless interface using Wi-Fi or cellular to get the data from the batteries to the charger and then to the operator within that enterprise customer. Many chargers support multiple charging profiles or different modalities, so lead acid and lithium-ion can be supported at the same time. And with most modern products, you see that the efficiency is around 95% or higher is kind of minimum standard. And of course, safety approvals. So you do want to make sure that any products that you're deploying in your distribution center or warehouse has some level of safety approvals on it, whether it's UL, CSA, or IEC. These are all common standards that make sure that the product is designed and manufactured so it does not cause any damage or harm to any of your employees. So this is the data sheet for our product. I am not going to sit here and read this data sheet. This is really here supplied, so if someone gets a PDF of the file, they'll have some speeds and feeds in the products. But a few highlights I'll point out. One is the battery voltage is selectable via auto detection, anywhere from 20 to 120 volts. The max charging current up to 600 amps. Okay. As I mentioned, we have two models, a 15 and a 30 kilowatt version, and those are some of the more significant parameters that I would kind of mention from the data sheet. If we jump to the second page of the data sheet, a few things I'll point out is the embedded IoT capability. We support IoT or remote management via both wireless and wired interfaces. And also I'll point out the UL certification on our product as well. We support UL 1564 for the North American market. So those are just some highlights, and really, as I mentioned, these two slides are for anyone who gets a PDF copy and they want to look at the speeds and feeds. Now, let's just peer a bit into the near future here. So our product that we were just talking about, as well as the batteries that we supply, they currently are all designed and manufactured for wired charging, okay? But the next question is, what about wireless charging? So we actually have products that are in trial with some of our customers, and this is basically wireless charging offered to accompany the lithium-ion batteries that we supply for different types of material handling equipment. So the current system that we're trialing with customers, it's basically a 30 kilowatt charging, and this is effectively charging without a physical connection. So much like a cell phone or a smartphone can sit on a wireless charging pad, we've enabled similar functionality between a charger and a wireless panel that is installed on the material handling equipment. And what you really see, the real value of this is that it takes opportunity charging to the next level. Ultimately, it decreases maintenance and parts costs by removing the charger, power, connector, and cables. So these commonly do get damaged when they're used for charging. So it physically takes that out of the equation. And it basically improves not only the safety, but also the utilization of the operator's time. What we saw in these field trials is that the power transfer rate, so this is from the power coming into the charger being delivered to the battery on the truck, was 93% efficient. So that's a moderately high level of efficiency when you think about, excuse me, when you think about the power being transferred across a 3-inch air gap between the transmitter and the receiver. What we also saw was the forklift operators, of course, were able to get within plus or minus 1 inch of alignment of these panels. And that's important because the panels do have to be aligned or closely aligned for maximum power transfer over a wireless interface. And so what we saw is they were able to fully charge a battery through a wireless interface in an hour and 10 minutes. And this is compared to, say, about an hour with a wired or cabled charging session. So we saw, very fast charging, very high efficiency, and this is a product that we will be taking to market later this year. I'm going to hand you back to Robin, and she'll talk about fast charging battery technology.
Thanks. So we're going to continue on with the technology roadmap portion of this presentation on the battery side. And we're going to start with what I briefly mentioned earlier, which is fast charging battery technology, which we call multi-voltage SafeFlex. So Lithium SafeFlex is a comprehensive battery solution designed to meet cost, performance, efficiency, and durability requirements of the warehouse environment. It includes application-specific cell chemistry and intelligent battery management electronics. Lithium SafeFlex systems are high cycle life, maintenance-free solutions for industrial vehicles. The multi-voltage technology enables the battery, this type of battery, to charge at double its output voltage, which actually cuts charging time in half and makes opportunity charging an even more accessible option than with regular SafeFlex batteries. And it increases the simplicity and ease of use for the operator. So the multi-voltage battery completes a full charge in less than an hour, and it's offered in 24, 48 volt, 36, 72 volt, and 48, 96 volt combinations. Right now, we've deployed over 200 of these batteries across these 3 different voltage combinations. It's common for high use and high capacity batteries, such as a large 48 volt battery, which normally would be charged with 2 cables to increase the charge current. But the multi-voltage battery uses a single connector and 4-aught cabling, which delivers cost efficiencies and minimizes the chance of cable damage over traditional fast charging with dual cables. Other than the battery configuration itself, the multi-voltage battery uses standard chargers and requires no changes to the other equipment. So for example, a battery would charge at 96 volts and discharge at 48 volts with a 30 kilowatt hour 48 volt 600 amp hour battery can be fully charged in less than an hour at 320 amps with a standard Anderson connector. So in essence, if something familiar to you, you can charge a class 1 248521 battery fully in 1 hour over a single cable connection. Now we're going to talk about some other technology available on the battery side, which Jeff mentioned briefly on the chargers, which is IoT, to improve asset utilization, service, and support. So how does this work? The Internet of Things allows for remote monitoring of batteries via Wi-Fi connection, which can be shared with the operators and other stakeholders. This can be used to right-size the batteries for optimization of CapEx expenditures, and real-time fleet management can be used to reduce OpEx expenditures as well. Essentially, there's a wireless gateway which connects to the internet to provide the data. The battery management system is already collecting very detailed information about the usage and about the health of the battery and looking for maintenance issues. This information is just used and collected and can be looked at on a local laptop or monitored off-site by employees who may want to look at overall company asset utilization. Here you can see the data output from our IoT system across multiple sites real time. We have an example of a customer who looked at asset utilization during trials and noticed that the batteries that were actually underused at their initial location and then relocated them to a second site when it was ready to get updated power technology and use lithium-ion batteries, and actually saved them significant costs because they were just able to use batteries that they already had. And you can also see that this type of system could be used for ongoing maintenance and to make sure that workers are using the batteries properly. Okay, now let's look at improved safety and environmental benefits of lithium-ion batteries. And in order to appreciate this, we first need to look at the problems with maintenance and safety for lead-acid batteries. The charging of lead-acid batteries is quite hazardous, but many workers may not even think about this because they think of the activity as so routine. The three most common risks are hydrogen gas formation when the battery is being charged, exposure to sulfuric acid from spills and leaks, and physical injuries from the battery's weight. Repetitive use injuries such as sprains and strains are also really common. The highly corrosive electrolytes in the batteries can cause respiratory irritation, eye damage, skin irritation, and they can even erode tooth enamel. The sheer size of material handling batteries means that crush injuries are really common. This is an overview of the risky maintenance that's required for lead-acid batteries. So first, the fluid level is extremely important, and the safe level requires regular watering. Both overwatering it and underwatering it can cause damage to the battery. Conventional batteries use a liquid electrolyte, which is a mixture of sulfuric acid and water. And when batteries are being recharged, they generate hydrogen gas that's explosive in certain concentrations. So ventilation systems need to be in place to provide enough fresh air to prevent explosions. The electrical voltage of the battery itself can ignite the flammable materials and cause burns. That's really common. And splashing acid is a risk. So personal protective equipment like goggles and a face shield and gloves need to be working on batteries. And you also need first aid facilities, eye wash stations, emergency showers, and things like that, which all takes up a big footprint in the warehouse and uses up valuable space that could be used for other things. Lithium-ion, on the other hand, is a really sophisticated system and basically has no maintenance at all. They're sealed and have a lot of safety factors in their design. Lithium iron phosphate itself is the safest with the longest cycle life due to its very stable chemical makeup. A critical component called the separator, which is in between the anode and the cathode, prevents shorting within the cell itself. The electronics also provide protection against safety events. There are incorporated fuses, and these protect against overcharge, overdischarge, high and low temperature charging, and any other situation that could create a danger. And so they end up being maintenance-free over the lifetime of the truck, and they really basically just completely reduce the opportunity for user error. Lithium-ion batteries are also much safer for the environment, and so let's look at the environmental advantages of lithium-ion. First, lithium-ion is a fairly broad bucket of battery types, but there are some different versions available for different applications. High capacity, lower power, long runtime batteries based on cobalt cathodes are often used in consumer electronics or medium rate chemistries. For applications like e-bikes. But for material handling, we've selected a special subset of lithium-ion called lithium iron phosphate, or LFP, because it's very well matched to the material handling industry. We chose this type of lithium-ion cell because it has the highest power, the shortest charge time, and the longest cycle life, making it very well suited for the warehouse environment. So for any lithium-ion batteries, you'd have higher charging efficiency, to reduce energy usage and better energy absorption, which lower electrical costs. Obviously, you'd also have reduced water consumption, no hazardous spill precautions and procedures, less material waste and scrap due to the increase in cycle life, higher energy density, and reuse for other applications at the end of the material handling useful lifetime. But in addition, for LFP chemistry, it's non-toxic, non-contaminating, doesn't contain any rare metals. Iron is readily abundant. LFP chemistry is UL, CE, SGS, and RoHS approved. And it's easy to dispose of because it doesn't have any heavy metals. Now let's look at how this all plays out in terms of the total cost of ownership for lithium-ion versus lead-acid batteries. So again, we need to look at the challenges of lead-acid in order to have a context with this. They contribute to the high total cost of ownership for the lifetime because of low capacity, they're heavy and large, the normal maintenance, the monitoring, which requires the charger interface and takes 3 to 5 minutes per battery with a direct physical connection, as opposed to the IoT system that we discussed for lithium-ion. There are environmental and recycling issues. You're required to do government reporting for lead-acid. Workplace injuries are common, and they can lead to increased insurance costs. And then the long charging and cooling time, that means for every 24-hour period or one 8-hour working shift and 2/3 downtime, you need 1 battery or 3 batteries for a full 24 hours. And then, of course, you have the battery room and the large footprint inside the warehouse itself. For lithium-ion, we have several benefits versus lead-acid. The long cycle life, the fact that it will accept partial charges without degrading the battery life. It eliminates battery changes and maintenance associated workplace injuries. There's long run time, tailored to utilization, faster charge times with opportunity charging. And the electronics required for safety and communication enable remote monitoring and troubleshooting. There's also better cold temperature performance, and I'm going to go into that in more detail in the next couple slides. So let's look at how we can quantify these gains. First, there are the capital expenditure improvements brought by the features of these systems. Everything from the batteries themselves to the charging rooms can be right-sized. You can eliminate the battery handling rooms, the ventilation accommodations, the eye wash stations, and the safety gear. You can reallocate battery handling rooms to become a staging area, a break room, etc. And then there's the operating cost improvements. So there's an increase in the productivity or lower cost of operation by about 30%. There's lower electrical utility costs by 20% because the lithium battery is 98% efficient versus 80% for lead-acid batteries. There's improved safety conditions, and improved environmental conditions, and then improved asset utilization. So you get 100% with lithium-ion versus about 33% for lead-acid, and then lower truck maintenance costs because the power delivery from the lithium-ion battery is actually more consistent and has less wear and tear on the truck motor. So this is an example of an 80 truck fleet located in the state of Florida. And there are a few things that I want to bring to your attention. So notice that the CapEx expenditure between lead-acid and lithium-ion is roughly the same over a 5-year period, but the main difference is that the lithium-ion solution has a higher upfront expenditure on battery assets, while the lead-acid solution has the expenditure on lead-acid batteries spread out over a 5-year period. Also notice that the annual maintenance costs for propane and lead-acid are roughly the same at around $600K per year, while these maintenance costs are negligible for the lithium-ion solution. And notice that the fuel cost for propane is substantially higher than lead-acid and lithium-ion batteries, but lithium-ion batteries require less electrical energy for charging than an equivalent lead-acid solution, and the lower consumption of power is attributed to the higher efficiency of lithium-ion. The net benefit is that our lithium-ion solution provides about a $2.8 million CapEx and OpEx improvement over propane, and about a $4.2 million savings over lead-acid solutions. And for companies that have green initiatives underway, the propane and lead-acid solutions generate an incremental 8 to 11 tons of carbon emissions over this 5-year period. And I think I forgot to mention this is actually for a cold storage refrigerated facility. So let's just do a quick summary of all of the things that we've looked at, and then we'll turn it over to Q&A. So again, the benefits of lithium-ion power solutions with IoT are decreased in time-consuming battery maintenance protocols, reduced workplace injuries, increased fleet uptime with wireless opportunity charging and IoT management. It'll enable your organization to embrace green initiatives, decrease your electricity consumption, and reduce the use of consumable equipment and parts, and optimize the use of floor space. And finally, even with all of these things, it's possible to potentially reduce the number of trucks required for your organization's goals. And now I'll just turn it over to Michael for the Q&A.
Outstanding job, Robin and Jeffrey. Guys, great job today. Terrific stuff. And you can tell, too, because we have a lot of questions rolling in. And as I mentioned at the beginning, we do have time for a short Q&A, and we do have a lot of questions rolling in. So if we don't get to your question today, we're going to move those over to Robin and Jeffrey, and they'll be able to respond to you via email following today's event. So, guys, we have we have some really good questions here. Let me just get it rolling, and I'll just toss it out to see who wants to take it. This first question for Robin or Jeffrey, are the maintenance requirements, I thought this was a good question, are the maintenance requirements for NMC the same as LFP batteries? Who would like to take that one?
So I'll take that. So I mentioned the cobalt-based batteries that are common in consumer electronics, and those are sometimes actually used in material handling as well, and the maintenance requirements are the same, but typically the cycle life is somewhat lower for NMC batteries. So while you wouldn't have to do watering or something like that, like you would for lead acid, you would expect that the cycle life would be lower, and possibly the battery would need to be replaced sooner if you have a truck that's in the field for a very long time.
Gotcha. Yep, that makes a lot of sense. Okay, this is a really good question too. I thought this was a great question. I'll toss this out to either Robin or Jeffrey. Guys, can you discuss the charger's applicability to a highly mixed fleet with legacy lead-acid products still in use? That's a great question. So how does that work? We'd like to handle that one.
Yeah, I can handle that one. So the charger I previewed today, so it does work in a mixed fleet environment, and so let's define what mixed fleet is. So mixed fleet could be a mix of anything from a pallet jack to, say, a forklift. And, what that typically means is a voltage range of, anywhere from 24 to, say, 96 volts. So, yes, it can definitely operate in that type of mixed fleet environment, right? And it can support all three classes of equipment, charging those three classes of equipment at the same time. The other way to interpret mixed fleet would be, say, like a multi-chemistry fleet. So you would have, very commonly, you have a mix of lithium-ion and lead-acid operating at the same time within your fleet of material handling equipment. And our charger can support that as well. So it's predominantly used with our batteries, which are only lithium-ion, but if need be, we do have charging profiles, lead-acid charging profiles that can be programmed into the charger as well. So it can support that definition of mixed fleet as well. So that's a good question. Thank you.
Yeah, that is a really good question. And another question here I thought was interesting too, because we were writing about and hearing a lot about fuel cells, and this attendee said, "Hey guys, I'm hearing a lot about fuel cells. Why aren't they gaining market share faster these days?" That's a great question. Who could handle that one?
Sure, I'll take that. So I did mention fuel cells briefly in the beginning, and they are gaining some market. I'd like to look at fuel cells as kind of a more equivalent to an internal combustion engine. So they're not an energy storage device, they're an energy conversion device.
I see.
And they actually need to be used with a battery in the same way that your car, in the same way that a hybrid electric vehicle has a battery and a gas-powered engine. So a fuel cell is kind of the equivalent of the gas-powered engine, and then they would be used with, they would actually charge a battery, and you would use hydrogen as the fuel. The problem with them is that our society does not have hydrogen infrastructure yet. So if an organization wants to use fuel cells, they would first need to put in the hydrogen infrastructure required to bring that fuel in. And most places won't see a return on investment for putting in that infrastructure within a reasonable amount of time. Right. On the other hand, if you have something like an Amazon facility with very, very high throughput, very, very large volumes, they actually will put in fuel cells because they have so much throughput that they'll see a return on investment from putting in the infrastructure for the fuel cells.
Right. That makes sense.
But like I said, that doesn't really negate the battery piece of it. So they will be used in tandem. And my personal belief is that eventually we'll get to a place where instead of having a combination of lead acid and internal combustion engines, we'll have a world of fuel cells and lithium-ion batteries.
That makes sense. That makes sense, and that would be super efficient. Guys, we do have time for a couple more questions here. Jeffrey, this one might be more geared towards you. Question, Jeffrey, are the new chargers you mentioned sold through distributors?
Yeah, great question. So I'll answer that question in terms of our batteries and our chargers. So most of our Motive products are actually sold through material handling equipment dealers. So much like the truck, for example, there's the OEM manufacturer, then they have a dealer network, and then they sell to the enterprise customers. We leverage that same dealer network. And so both our batteries and our chargers, typically they meet up with the truck at the dealer. They get installed, and then that truck with both the battery as well as the charger is then delivered to the enterprise customer. So that's our most common distribution model for both the chargers and the batteries.
Gotcha. That makes sense. And guys, we do have time for just one more question, and we do have to wrap up. And Robin, I think this question is directed towards you. Robin, why did you use cold storage as a usage example? I think that's an interesting question. I think I know why you did, but why did you use cold storage as a usage example? Yeah,
I briefly mentioned that just because cold storage is actually an early adopter of lithium-ion technology. And that's because lead-acid batteries, can't be used or charged at very low temperatures, or especially charged, where lithium-ion batteries, ours actually incorporate heaters that keep the batteries at an optimum temperature. So they can actually be used and charged in a cold storage or refrigerated facility, which means that you don't have to stabilize the temperature of the equipment going in and out of the freezer, and that helps keep down frost and things like that. That can actually cause dangers for people.
Right. Gotcha. Makes a lot of sense. Well, guys, we do need to wrap up. I want to thank you both. Thank you, Robin Schneider, PhD, Director of Marketing at Green Cubes Technology, and Jeffrey Van Zwal, Chief Marketing Officer, Green Cubes Technology. Guys, you did a terrific job. And again, we do have a lot of questions still rolling in, so we're going to roll those over to you guys, and you'll be sure to get back to our attendees today. And also, too, before we wrap up everything, and don't forget you can download a PDF of today's presentation, so make sure you do that while you're on the interface. Robin and Jeffrey, guys, thanks again. Great job today.
Yeah, thank you. Our pleasure, Michael.
Great. Thank you, and I want to thank everybody for attending. Have a wonderful day.
Bye-bye.